Section 10.4, we will look at perimeter and area of similar figures. So if the similarity ratio of two similar figures is A to B, then the ratio of their perimeters is A to B, and the ratio of their areas is A squared to B squared. In number 1, the trapezoids are similar. We want to find their similarity ratio larger to smaller. So that would be 10 to 4, which we can reduce as 5 to 2. Part B, find the ratio of the perimeters larger to smaller. So the ratio of the perimeters is the same as the similarity ratio. That would be 5 to 2. And then in C, find the ratio of their areas larger to smaller. We will just square the ratio of their perimeters. So that's 25 to 4. In number 2, the triangles are similar. Part A, find their similarity ratio larger to smaller. So for this one, I just chose the shortest sides in these triangles because we're already told that they are similar. So their similarity ratio is 5 to 4. Then in B, the ratio of their perimeters will be the same as the similarity ratio, 5 to 4. And the ratio of their areas, we're just going to square these two. So it'll be 25 to 16. Number 3 says the corresponding sides of two similar parallelograms are in the ratio 2 to 3. The area of the larger parallelogram is 51 inches squared. Find the area of the smaller parallelogram. So remember, their similarity ratio is the same as their perimeter ratio, and then to find the ratio of the areas, we just square each. So their ratio of areas is 4 to 9. So if they have a ratio of 4 to 9, so that is smaller to larger, and it says the area of the larger is 51, then I can say 4 is to 9 as x is to 51. And then we solve the proportion. 9x equals 204, and x is about 22.7 inches squared. So that's the area of the smaller parallelogram. Number 4, the ratio of the lengths of the corresponding sides of two regular octagons is 8 to 3. The area of the larger octagon is 320 feet squared. Find the area of the smaller octagon. So if their ratio is 8 to 3, then square them to find that the ratio of the areas is 64 to 9. So that is larger to smaller. We know that the larger area is 320. We want to find the smaller. So solving our proportion, 64x equals 2,880. Then we get that x equals 45. So the area of the smaller octagon is 45 feet squared. In number 5, Benita plants the same crop in two rectangular fields, each with side lengths in a ratio of 2 to 3. Each dimension of the larger field is 3.5 times the dimension of the smaller field. Seeding the smaller field costs $8. How much money does seeding the larger field cost? So the key here is that the dimensions of the larger field is 3.5 times the dimensions of the smaller field. So we can say that's 3.5 to 1. And then if we square each of those, we get 12.25 to 1. So that's how much bigger the larger is than the smaller. we know that the smaller field costs $8, so we can say 12.25 is to 1 as x is to 8. Then taking the cross product, we get x equals 98, or it will cost her $98 to seed the larger field. Number 6, the similarity ratio of the dimensions of two similar pieces of window glass is 3 to 5. The smaller piece costs $2.50. What should be the cost of the larger piece? So remember, when you're fitting a piece of glass, you're looking at the total area of the window. So if their similarity ratio is 3 to 5, then their similarity ratio of the areas is 9 to 25. So we can say smaller to larger equals smaller to larger. Then solving our proportion, we get 9x equals 62.5. So x equals 6.94. So it will cost $6.94 for the larger piece of glass. In 7, it says the areas of two similar rectangles are 1,875 feet squared and 135 feet squared. Find the ratio of their perimeters. So when we went from ratio of perimeters to ratio of area, we squared both numbers. So here we'll have to take the square root. So let's first write the ratio here. So that's 1875 to 135. This can be reduced to 125 to 9. So we first want to look to see if we can reduce our ratio. Then take the square root. So square root of 125 can be simplified as 5 square root 5, and then square root of 9 is 3. So we can leave our answer like this, or we can say that it is 5 square root 5 feet to 3 feet. In number 8, the areas of two similar pentagons are 32 inches squared and 72 inches squared. What is their similarity ratio? Okay, so let's write the ratio of their areas, 32 to 72. We can reduce this as 4 to 9. Then to find their similarity ratio, take the square root. Square root of 4, square root of 9. So we get 2 to 3. So 2 inches to 3 inches. Or we can write that 2 inches to 3 inches. Then in B, the ratio of their perimeters would just be the same thing. 2 inches to 3 inches. And lastly, number 9. The areas of two similar triangles are 45 centimeters squared and 121 centimeters squared. What is the similarity ratio? Okay, let's write our ratio, 45 to 121. That cannot be simplified, so we'll just take the square root of each. Square root of 45 can be simplified, 3 square root 5. And the square root of 21 is 11. So that's 3 square root 5 centimeters to 11 centimeters. Or we could write it 3 square root 5 centimeters to 11 centimeters. And then the ratio of the perimeters is just the same thing. 3 square root 5 centimeters to 11 centimeters.